All right. Segment CE is parallel to segment BF, which is parallel to segment AG. So we have some information that these are parallel. And you have 4 missing segments to find. Now, just a hint, when you're solving for N and M, you may use the triangle proportionality theorem, what we learned on Monday. It's kind of, I called it a shortcut. To solve for K and J, you may not use the triangle proportionality theorem. So just be careful. I would find M and N first, and then we can worry about J and K, which are tougher to find after that. So go ahead and find N and M, and I'll go over them. All right, let's go for M first, because this one's really basic. We know by the triangle proportionality theorem that this segment divides our triangle sides proportionally. So we can say 48 is to 32 as 36 is to M. Very basic, just using the parts of the sides of triangle DBF. So we cross multiply 36 times 32 divided by 48, and we get M, 24. Believe it or not, you might not trust me, but you can do the same thing with N. The same thing with N. You can say 40, well, we're probably going to do the other side actually. We're going to do 36 is to 30. You see that? 36 is to 30 as, you just need to match it up, as 48 is to N. Yeah, I'm allowed to use those chunks. I'm allowed to skip that middle chunk because I know that these lines divide up my triangle proportionally, only because they're parallel. If they weren't parallel, I couldn't do that. 36 is to 30 as 48 is to N. I hope you can see that. Where I got those, I mean. 30 times 48 divided by 36, 40. N is 40. Okay, now for the ones that are a little bit trickier. No, you cannot say 48 is to 32 as 30 is to K. No, you may not say that because those are not part of the triangle proportionality theorem. Okay, so we are going to instead do 48 is to, we need this whole side. We're going to compare 48 to that whole side. How much is that whole side? All right, 48 is to 90 as 30 is to K. I hope everyone's okay with that. If not, you need to ask me. Okay, so 30 times 90 divided by 48. I think we did something wrong. Oh, 48 is 2. Not 90, it's 80, not 90. Thanks for helping me out, guys. 30 times 80 divided by 48. K is 50. K is 50. Now we need to find J. My picture has gotten very messy. But we're going to do the same thing we did up here, but now we're just going to do it for J. So 48 is to, I don't want to say is to 80. I'm using J, so I need this whole side. I'm looking at the big triangle now. 48 plus 32 plus 40. 120. 48 is to 120 as 30 is to J. Whew, it's a lot of steps, huh? 120 times 30 divided by 48. 75. Okay, homework answers coming right up. Maybe. That sure makes your homework look really small, huh? How was that homework? Pretty easy? Want me to work any of these? Number 1. This is just a basic, you can put height over height equals shadow over shadow. So you can put 5 is to x as 6 is to 576. So that's number 1. Alrighty, number 4. You are 1.6 meters tall and cast a shadow of 3.5. So here's your shadow and here's you. It technically creates a triangle because you're going to be perpendicular to the ground. If a house simultaneously, so that means at the same time, so that means the sun is at the same angle. So these angles are the same. And these angles are the same. So we've got similar but angle. Cast a shadow of 17.5. How tall is the house? So you're drawing 2 separate triangles. You're drawing their shadows. Make sure you put the shadows on the ground. And then you know your 2 triangles are similar by angle, because the sun is in the same spot since you're measuring the shadow at the same time. Therefore, we can put, once again, height over height equals shadow over shadow, and cross multiply. Okay? Last one, number 6. Find the distance across the river. Alrighty, this was probably the hardest one on the worksheet because there's a little bit of algebra involved. So if I said 60 is to 80 as x is to, this is where you need to be very careful. I need every student staring at this problem because this is where people make mistakes. 60 is to 80 as x is to, and you would not say 32. You would say the whole side. Good. You would add them together. 80 is a whole side. So you need to compare it to a whole side. And that's where we could make a mistake. Do you need me to work out the math? By the way, some students in my class were like, why don't you reduce that before you cross multiply? And you're welcome to reduce 60 over 80 before you cross multiply. If you want to do, 3/4 equals x over x was 32, you're welcome to do that. Doesn't really matter at all. So 80x equals 60x plus, I feel like we did this in a warm-up. Yeah. Didn't we do this one in a warm-up already? Yep, we totally did. I think it was 96. Yep, 96. That was weird. 9 meters. Okay, mixed practice. So here's all the random problems that we were like, we don't know where else to put these, so we'll put it on the mixed practice day. I'm going to go through it pretty quickly, just so that y'all, as usual, have enough time. Triangle EAB is similar to triangle DAC. Determine if the statements are true or false. These are the questions that the district loves to put on our tests, on our TEKS test that we're going to get for our final and all of that. These are good problems where you're not just solving for X. These are critical thinking ones. All right, so true or false? Let's see. AE is to ED as AB is to BC. True or false? That is the triangle proportionality theorem in a nutshell. This is true. Let's try number 2. EB is parallel to DC. Well, if the triangles are similar, then they're definitely parallel because all of the angles are congruent. So, true. Okay, next one. AB is to BC as EB is to DC. Is that what the triangle proportionality theorem says? False. Good. You cannot use it on those parallel segments. That is not the triangle proportionality theorem. So this one is false. And lastly, angle AEB is congruent to angle ADC. Yes, if 2 lines are parallel, then corresponding angles are congruent. True. All right. If HIJK is similar to HIJKLMNO, what are the coordinates of N? Now I know this is hard for you to do because you can't actually like touch it with your pencil and count the squares, but let's talk about how you would count this because this one's kind of tough, okay? So these are not congruent. You can't just say, I rise 3 and I run 4. So I'm going to rise 3, I'm going to run 4. You have to use kind of like a scale factor, okay? So we need to be careful. What I would do first is I would do what I just said. I would find the scale factor. Let's find it. ML is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. ML is 12, and HI is 1, 2, 3, 4, 5, 6. Well, that's easy. What is the scale factor? 2. So that means that this shape is twice as big as HIJK. Scale factor is 2, second over first. So now let's see what the slope is from I to J. Ready? From I to J, I rise 1, 2, 3, and I run 1, 2, 3. So the slope is really just 1, right? Rise 3, run 3. So what are the coordinates of N? We would just use our scale factor. We would double it. Yep, the slope is 1. Take your rise and you use the scale factor on it. And you take your run and you use the scale factor on it. If the scale factor had been 2.5, we'd do 3 times 2.5 and then 3 times 2.5. It's kind of unique since our scale factor is 1. We're going to end up off the graph, okay? So we could find the coordinates of N by taking the coordinates of M, and we can add 6 to both the X and the Y, okay? So the coordinates of M are, let's see, 1, 2, 3, 9, the coordinates of M are 9, 15. So N is going to end up off of our graph. This will probably be a multiple choice question on your test. What would the coordinates of N be? 15, 21. Okay, so let's talk about what we did there. Step 1, what did we do? We found the scale factor. We didn't use the coordinates, right, to find the scale factor. We used the side lengths. We picked a vertical side. You could have picked the horizontal one. Then we found the rise and the run, and we multiplied the scale factor by the rise and the run. Okay? In the model of the building, the height is 10 inches. Height of the actual building is 280 feet. If the width of the model is 12, then what's the width of the actual building in feet? The only thing I want you to walk away from a problem like this is just knowing to be consistent. You can set up your proportion however you want, as long as you're consistent. I like to do inches over feet equals inches over feet. But you can do inches over inches equals feet over feet, as long as you're consistent. So which ones go together? This one goes with this one. And then where do I put this one? Well, I don't even have to guess. Do I put it in the numerator or the denominator? I don't even have to guess. I put it wherever the inches is. When you are cross-multiplying, do you have to convert units? Do you have to convert all these to inches or convert them all to feet? No, you do not. That's a clue. The units will cancel. 280 times 12 divided by 10, 336 feet. The inches will cancel, and your answer will already be in feet. You won't have to convert a thing. Now let's do what Ralph typed. Now let's find the scale factor. Because when you're asked for a scale factor, you do have to convert. Scale factor is second over first. I cannot reduce this. I cannot reduce this as is because the units don't match. They're fighting. One's like feet, and the other one's like inches, and they don't agree. You need to make them agree, okay? So I could convert probably the feet into inches. It's going to be very large. 280 times 12, 3,360. So that's inches over inches. The zeros cancel, so And this is a coincidence. It won't always happen. But the scale factor is also 336. It's the width of the actual building, and it's the scale factor. That was unique to that problem. I don't think we need to do this because this is the same type of problem. We're going to skip this one. Let's do this one. An architect built a house from the blueprint shown. He used a scale of 1 inch equals 8.5 feet. What is the scale factor to enlarge the blueprint? No, Aaliyah. Oh, real quick, Aaliyah. Scale factors don't have units. When we did the scale factor on that problem, the inches canceled. Scale factor is just a number. It's unitless. Remember we talked about that yesterday? I'll show you on this problem. I'll show you. So you need to put second over first. This is feet and this is inches. Those don't agree. So you need to convert your feet to inches. 8.5 times 12. Now we have 102 inches over 1 inch. The inches cancel, and 102 divided by 1 is just 102. The scale factor, that means that blueprint, that sheet of paper, would be blown up 102 times, and that would equal the actual size of the house. So the scale factor is 102. It does not have units. What are the dimensions of the bathroom in the house? Okay, so they gave us these dimensions. What was our scale factor? 102. You can take dimensions and just multiply by the scale factor. That's what scale factors are for. They are meant for multiplication, multiplication, multiplication. So I can take the width and multiply it by 102. I can take the length or whatever and multiply it by 102. Let's find out what the actual dimensions of the bathroom would be. 3/4 times 102. So it would be 76.5 inches by, we know what 1/2 times 102 is, by 51 inches. Now, those don't mean a lot, so we could divide it by 12 if we want to do it in feet. That is a tiny bathroom, my friends. Let's see. 76.5 divided by 12. Yikes. That's called a powder room. That's a very, very, very small bathroom. I don't even know if that's realistic. But that would be the answer in feet. It would depend on what your question asked you to do, whether to put it in feet or inches. But what did I do? I multiplied by the scale factor, and then I did convert it to feet just to give me an idea. I don't really know what 51 inches looks like, but yeah. Okay. Let's do a few of these because these are on your quiz, and then I'll let you get started. Determine if the triangles are similar. What do we need to do? Find the missing angles. 180 minus 38 divided by 2. Uh-oh. So what would we write in our answer? I think the directions on the quiz are going to say to write none. Yes? What? I know. I'm not quite ready yet. I'll come over as soon as I'm done teaching them. Okay. Okay, determine if the triangles are similar. I'm going to have to breeze through these. I have to go teach next door because she's sick. Okay, shared angle. Shared angle right there. Why am I allowed to add the double arc? You can't add things for no reason. Why am I allowed? Corresponding angles. If two lines are parallel, then corresponding angles are congruent. What do you type on your quiz? Angle, angle, squiggly. All right, these two triangles have a shared angle. And then you do not just assume that those sides are proportional. You need to set up a proportion to make sure. 3 is to 7.5 as 5.5 is to 13.75. We don't know if those ratios are equal, so we need to do some cross multiplying, or you can divide. When I divide those, I get 0.4. And when I divide these, I get 0.4. I get 0.4 both times, which means these are similar by side, angle, side, similarity. Here's an example of when they're not similar, okay? So we've got an angle, cool, check. 40 is to 18 as 35 is to 15. Let's make sure that those proportions are equal. I don't really care what I get, but I do care whether they match or not. Oh no, those do not match. Therefore, we would write none.